right, so we are going to summarize our lesson on the Polygon Sum Conjecture with this video. Throughout our investigation, we walked step by step through measuring all of the interior angles of whatever polygon that we drew. And we noticed that if we had a quadrilateral, the sum of the four angles was always 360 degrees. And if I had a pentagon, it was always 540 degrees. And eventually we realized that because I can create all of these internal triangles inside the polygon, that there is a formula I can use to figure out the sum of the interior angles of any polygon, no matter how many sides it has. So we have the three conjectures that came from that. The first one, the quadrilateral sum conjecture, we'll use quite a bit. Similar to the triangle sum conjecture, this quadrilateral sum conjecture states that the sum of the measures of the four interior angles is 360 degrees. So no matter what the quadrilateral is, it's always going to equal 360 degrees. The pentagon sum conjecture is listed in the investigation, but you don't use it quite as frequently. So honestly, I sometimes forget what the sum of the five angles is. It's 540 degrees, but I tend to use the polygon sum conjecture more than anything other than the triangle or quadrilateral. The polygon sum conjecture states that if I know the number of sides, subtract 2, multiply it by 180, and that's going to be the sum of my interior angles of whatever that n-gon is. Alright, so let's take a look at an example of how we're going to use this when solving problems. So I did choose an example from the assigned problems to work out with you. So if you have done them already, great, this is an opportunity for you to check your work. If you haven't done it, well, make sure you follow along with me. And I'm going to try and choose a color that, of course, will show on both the white and the black screen. We'll see. Okay, so we have this crazy shape going on, and we notice a bunch of things right from the get-go. We notice that we have two parallel lines. It's always nice to see the parallel lines because then it lets me know that I'm going to be using the parallel line conjectures. So we're talking about alternating interior angles or corresponding angles or alternating exterior angles or any scenario of that kind. Also, if I notice right angle markings, that tells me it's 90 degrees, so that helps me in that area. And then of course up here E and P are both congruent, so I see the nice markings there. So of course as soon as I figure out what E is, I'll figure out what P is. When I erase that, this thing's going to get marked up enough as it is. So let's erase and start from the beginning. Got a lot of letters going on here. Let's make a list to kind of keep them organized. We don't necessarily have to solve alphabetic order, but it's nice to write out the list of what you're looking for so that as you solve it, you can come in and check them off. Right out of room here, so we'll just put P over here off to the side. Okay, so generally though, solving in alphabetic order does kind of help us quite a bit with the organization. Let's take a look. So A is right here in the middle, and it's opposite, it's a vertical angle of 116. So easy enough. Vertical angle conjecture, 116 degrees. Okay, so because it's parallel lines, that means for the linear pair, over here would be 64 degrees, which then of course means using alternating interior angles, that angle B is 64 degrees. So quite easy right there. And if we want to make it nice and easy, we can always say over here is 116 as well. Because notice I have a quadrilateral. In fact, it's a trapezoid. So to find angle C, I can add the three angles that I know. 116 here, 64 here, and 90 degrees here, and then subtract that from 360 degrees. When I do that, I get, as you were expecting, 90 degrees. So that makes it pretty easy there. Let's go ahead and find angle D. It's back over here to the left of A and B, and notice that we have another trapezoid, so another quadrilateral. So the same thing, add up the three angles I know, 116 plus 64 plus 98, subtract that from 360 degrees, and we end up with 82 degrees. All right, so if I know angle D is 82 degrees, Then I know that the opposite angle is 98 degrees. It's also corresponding to the 98 degrees we see listed. I already know that this is 64. I can say it's 64 because it's the linear pair to angle A. It's also the vertical angle to 64 that we've already listed. So I have another quadrilateral shape there. I know two of the measures, and then I know the other two angles are congruent. So add 98 and 64, subtract from 360, and then divide that by 2. So type that into your calculator to make it nice and quick, and we see that angle E is 99 degrees. But we also know angle P. So again, we don't have to wait to go alphabetically. I can just skip right down there to angle P and put 99 degrees. All right, let's see where angle F is. Okay, so angle F is down here in the pentagon shape. We know some angle measurements. We know that this is 82. Oops, that's supposed to be 2. And we know that the angle that's linear to 64 is 116. So I have 4 of the 5 angles necessary. So add up those 4 angles, subtract from 540, since it's a pentagon. That would be 540 for the sum of the interior. And that tells us that angle F is 88 degrees. All right? So now for angle G, well, I've got 3 angles that are basically forming kind of a nice little circle there. So if I add 122 plus 88 and subtract that from 360, angle G is equal to 150 degrees. Okay, so we know a bunch of other things going on in this quadrilateral to help us find H. Using vertical angles or linear pair or whatever reasoning you want to use, we know that that angle in the upper left corner is 64, G is 150, and then because it is corresponding to the right angle listed, we know that this is a right angle here at 90 degrees. So add those all together, subtract from 360, since it's a quadrilateral, and angle H is equal to 56 degrees. All right, so now moving on to angle J. Well, if this angle right here is 90 degrees, that means this angle is 90 degrees. And look that I have another quadrilateral. So out of the 3 angles, we have 90, 77, and 87. Subtract from 360 degrees, and angle J is equal to 106 degrees. Okay, so angle J is then going to correspond up here to the linear pair of angle K. So 180 minus 106 is going to be 74 degrees. So nice linear or parallel line conjecture is coming in to help us out here. And of course the angle that is vertical to angle K is going to be 74 degrees as well. And the angle that is vertical to the right angle is going to be a shocking right angle. Okay, so now another quadrilateral. And we can add 90 plus 74 plus 60, subtract from 360 degrees, and angle M is 136 degrees. And we have another scenario where I have 3 angles that are basically forming a nice little circle there. So add 106 to 136, subtract that sum for 360, and we get that angle N is 118 degrees. Alright, so grand scheme of things, that actually didn't take too long. Using a calculator definitely helps speeds that up quite a bit. And it's kind of like a logic puzzle. You just take it one step at a time, put in what you know. Sometimes you're going to put in angle measures that are true, but you don't necessarily need them, and sometimes you might have to put in a lot more work to show what's going on. Now, future problems will include solving for these measures, but then you have to write down step by step. In the actual assignment in your textbook, it wants you to say, well, how do you know that angle E is equal to 99 degrees, or angle F is equal to 88 degrees? And you have to be able to prove with your conjectures, just as I talked it out, why we're saying those angle measurements are the ones that they are. So again, be ready to prove step by step what it is. But other than that, it's pretty simple. So make sure you finish your assigned problems and we will go over this in class.